Welcome to Seeing the Future, Advances in Computer Vision Research. In this special episode, we explore groundbreaking developments in how machines perceive and interpret the visual world. Drawing insights from 132 research papers published on December 29, 2025, this journey highlights computer vision's growing influence across healthcare, industry, and beyond. Stay tuned as we delve into key themes, reveal transformative findings, and spotlight a featured paper of the day for deeper analysis. Imagine entering a radiology department where an AI system not only identifies abnormalities in your medical scans with superhuman accuracy but also explains its findings in clear, natural language, as if a seasoned radiologist were speaking directly to you. Just a few years ago, such scenarios would have been regarded as science fiction. Today, however, computer vision technologies are making this a reality. Machines now rival expert doctors in both accuracy and clarity, fundamentally transforming patient care and trust. This marks a profound shift in real-world experiences, where AI is not simply a tool, but an active participant in critical decision-making. Computer vision is now a core technology powering countless aspects of modern life. It enables features such as face unlock on smartphones, the creation and detection of deepfakes, and the navigation of self-driving vehicles. In healthcare, computer vision facilitates early disease detection, while in manufacturing, it ensures precise quality control. The field also fuels immersive entertainment, from augmented reality to seamless video editing. As digital information becomes increasingly visual, computer vision emerges as a cornerstone of intelligent systems shaping our future. The latest research provides a glimpse into the next directions for this rapidly evolving field. At its essence, computer vision aims to grant machines both the ability to see and to understand complex visual environments. This is akin to assembling a jigsaw puzzle, where every piece, pixels, patterns, motion, plays a crucial role in recognition. Unlike humans, who leverage years of experience and intuition, artificial intelligence systems must construct their understanding from scratch, incrementally building intuition and expertise. Key challenges include not just perceiving, but also interpreting and reasoning about intricate scenes, mirroring the complexity of human vision. A prominent theme in recent research is the advent of multimodal and foundational models. Systems such as SenseNova-MARS and forging spatial intelligence exemplify this shift by seamlessly integrating multiple data types, vision, language, and even audio. Much like an orchestra combining diverse instruments, these models harmonize varied modalities, enabling advanced capabilities such as navigation, instruction following, and complex problem solving. Foundational models learn broad, adaptable skills, facilitating AI agents that operate effectively in rich, realistic environments. Generative and diffusion models represent another transformative trend within computer vision. Diffusion models, for instance, generate high-fidelity images and videos from random noise, functioning like a master chef who layers ingredients to produce a visual masterpiece. Notable examples include Mirage, which edits driving scene videos with photorealistic accuracy, and F2IDF, which sharpens blurry photographs. These innovations open new creative and practical frontiers, though they require careful balancing of output fidelity, computational speed, and resource efficiency. Medical and scientific imaging stand out as both proving grounds and beneficiaries of advanced computer vision. Papers such as Virtualize, DermaVQADAS, and EndoRare demonstrate how AI can analyze medical scans, synthesize rare case data for training, and assure the quality of diagnostic outputs. Here, AI is positioned not merely as a tool, but as a diagnostic partner. These advancements address the challenges of data scarcity and reliability, raising the standards for accuracy and explainability in life-critical healthcare decisions. Among the 132 papers, several key findings illustrate the field's rapid progress. Nirala and colleagues have developed AI systems that translate scan results into comprehensive radiology reports. The EndoRare framework enables one-shot models to synthesize rare medical images for training purposes. DyeStream delivers real-time avatars with sub-100 millisecond latency, facilitating naturalistic digital conversations. Series applies causal reasoning to achieve robust video object segmentation, while Mombasa utilizes dual-branch networks to balance efficiency and accuracy in real-world environments. Each represents a mini-story of innovation reshaping computer vision. The featured paper of the day, Bridging Machine and Human Communication by Nirala et al. addresses a critical gap between AI-generated detections and clinician-friendly narratives. The central motivation is to transform AI from a mere analytical tool into a genuine partner in clinical communication. By leveraging YOLAV 5 and YOLAV 8 for detection and GPT-4 for narrative generation, the system aims to produce radiology reports that are clear, accurate, and accessible. This work exemplifies the transition from automation toward true collaboration between human experts and artificial intelligence. Technically, the approach follows a multi-stage pipeline for generating radiology reports. First, computer vision models detect and classify findings within medical scans, outputting bounding boxes and class labels. These outputs are then provided to the GPT-4 language model, which crafts full narrative reports suitable for both clinicians and patients. Human evaluators have rated these AI-generated reports highly for clarity, although the stylistic nuances are still evolving. This demonstrates both the power and the current limitations of combining vision and language models for medical communication. The impact of this work by Nirala and colleagues is substantial. It has the potential to liberate clinicians from the repetitive task of report writing, while simultaneously standardizing medical explanations to reduce the risk of miscommunication. This advancement lays the groundwork for deeper AI-human collaboration in high-stakes fields such as healthcare. However, challenges remain regarding trust, narrative nuance, and adaptability. The work also prompts ongoing debate about whether machines can fully capture the art and subtlety of human narrative skill. Looking ahead, the future of computer vision lies in moving beyond simple perception toward true understanding. Causality and interpretability are poised to underpin trustworthy AI systems. The fusion of multiple modalities, vision, language, audio, and more, will empower richer reasoning and more comprehensive insights. Efficiency enhancements will democratize access to advanced vision capabilities, while synthetic data generation will accelerate progress in emerging domains. The hopeful analogy is that of a symphony, where AI and human insight harmonize to sharpen our collective view of tomorrow. In conclusion, the road ahead for computer vision is defined by both remarkable advances and persistent challenges. Landmark contributions from works such as Nirala et al., EndoRare, DieStream, and Series point the way forward. At the same time, issues of trust, transparency, and equitable access must be addressed. The future depends on robust collaboration between human experts and artificial intelligence. Listeners are invited to explore the latest research, share their perspectives, and actively participate in shaping what machines will be able to see and understand next. The journey is only just beginning. This presentation was synthesized using GPT-4.1 from OpenAI for both narrative and technical clarity. Text-to-speech synthesis was performed using Amazon's platform, while visual assets were generated using Google tools. All content underwent expert human review to ensure accuracy and coherence, though minor oversights may persist. Comprehensive references to all cited research papers are included, underscoring a commitment to clear, accessible, and trustworthy research communication. To stay informed about the latest developments in AI and computer vision research, subscribe to AI Frontiers. Receive updates on new breakthroughs and deep dive analyses, and engage with a community of experts and enthusiasts worldwide. Thank you for exploring the future of intelligent systems with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by R14.org.